Okay, so first of all, let us recap on what we learned yesterday regarding pressure in liquid. Okay, honestly, if you ask me, I felt that yesterday I was totally unaware of what's happening and I don't even really know what I taught you. So, I feel a little bit sad. I feel a little bit pressured lah. Okay, I feel that okay, I must make sure that you all know what I was talking about yesterday and that all of you were not just focusing on the amount of hingos that was coming out of my nose yesterday lah. Okay, so please tell me what is the formula for the pressure in liquid, Adam? What was the one formula that we learned yesterday? Sorry, Adam.
Isn't it the formula for pressure of liquid?
Pressure in liquid.
P equals HP. P equals HPG.
Okay, it's not really P lah. It's called rho. Okay, let me remind you once again. Thanks, Adam. Okay, this is pronounced as rho. It is a Greek letter. Okay, like alpha, beta, omega, all these things are Greek letters. So rho, okay, which looks like a berudu that is swimming upwards, okay, is the symbol, okay, for density. Okay, what does the G? What is this G? What is this? Sorry, G is a symbol for what? Eliska.
Gravitational acceleration.
Okay, yang merupakan nilai berapa? Gravitation.
9.81.
Okay, 9.81. Thank you very much. Gravitational acceleration. Obviously, my handwriting is very horrible. Okay, and what does the H stand for, Angeline?
Depth of liquid.
Okay, depth of liquid. Angeline, stay on the line. Oh dear. Sorry. Okay, Angeline, stay on the line. If this is the water level, okay, and this is the base of the sea lah, okay, either the seabed lah or the bottom of the water bottle lah, okay, I want you to tell me, Angeline, the H bakan, okay, the depth of the liquid, is it, let's say this is the object over here lah, okay, so is the depth of the liquid measured from the base to this one, is this H or what color shall I use? Okay, black lah. Okay, so Angeline, tell me, which one is the one that we use to measure the value of H? Black or blue?
Black.
Okay, very good. Okay, so H is always measured from the surface of the water, not from the surface, not from the bawah lah. Okay, this is very important. Now, besides that, we also looked at three factors, okay, three things that affect the pressure in a liquid. Okay, what are the three factors that affect the pressure in the liquid? Wilson. What is the first factor? Sorry, the what?
Density of liquid.
Okay, the density of the liquid. Can you tell me what is the relationship between the density and the pressure?
The higher the density, the higher the pressure.
Very good. Okay, the higher the density, the higher the pressure. The second one, Zulaika? Depth of liquid. Very good. Okay, so depth of liquid is H lah. Okay, depth of liquid. Can you tell me the relationship? Astaga, check balik chat. Sorry. Yeah, what's the relationship between depth of liquid and pressure? Sorry, kita ada selingan lagu sementara menunggu. The greater the depth, the greater the pressure. Okay, very good. Okay, so the greater the depth, the greater the pressure. Notice that I'm writing the pressure with a big letter P. Okay, sebab pressure is very big letter lah. Okay, the third one. If I call Wilson and I call Zulaika, means I must call Wilson lah. Okay, Wilson, what is the third factor?
Gravity.
Okay, the gravitational acceleration. What is the relationship?
The greater the gravitational acceleration, the higher the pressure.
Okay, very good. Okay, so can you tell me two places where the gravitational acceleration is different? Sorry, I'm still asking Wilson. Two places where the gravitational acceleration is different.
At the space,
Sorry, what?
at space, other planet.
Okay. Actually, space got no gravitational acceleration because there's no gravity in space. Okay, but you're right lah. Okay, other planets is one place. Wow, when you say other planets, means we got all together, like at least 8 places lah. Okay, fine. Other planets and Earth lah. Obviously, Earth. Sorry, this horrendous handwriting. Obviously, Earth has its own gravitational acceleration, which Aliska just now said was 9.81 lah. Okay, 9.81 meters per second. Okay, so say for example, in the moon lah, I know moon is not a planet, but we're going to say lah, let's say in the moon, the gravitational acceleration is less. So if you go swimming in the moon, if the moon got water lah, if you go swimming in the moon, you can actually swim much deeper because without feeling the pain, because the gravitational acceleration there is less than less than the Earth. Okay, Earth has a bigger gravitational acceleration, so we feel the pressure even more. But of all the three factors, these two are the most important. Okay, the density and the depth, and especially the depth. The deeper you swim into the ocean, okay, the bigger the pressure is. Which is why submarine, you cannot just have any paper ship go as a submarine. Submarine has the wall of the submarine. Kalau kau pandang dari tepi bahkan, okay, the wall of the submarine is actually very thick. Okay, now this is the person in the submarine. So you have this very, very thick wall. Okay, because the deeper you go inside the water, the submarine must be able to tahan the amount of pressure. Okay, that is very high. So the walls of the submarine must be very thick. Okay, it's not like the walls of your house that is very thin one. Atau kalau kau punya rumah kan adalah macam dinding kayu bahkan no lah, cannot tahan. Okay, it has to be like very thick, steel walls. Then you listen. Okay, sorry, wait. Okay. So let's talk about a few questions. Actually, my aim today, besides to explain to you what your assignment is for this particular subtopic, I also want to discuss a few things. Okay, so air bubble is at a depth of 5 meters below the surface of the lake. So this is the lake, this one, and the air bubble is over here. Here is 5 meters. How you know it is from the surface? Because they check up below the surface of the lake. So what is the pressure of the water on the bubble if the density of water is 1000 kilogram per meter? This one. I want you to calculate this, but don't look at this answer because this answer is a bit out. Okay, can you please calculate this for me, and then I will call somebody to answer. Okay, remember our formula is P equals to rho GH.
49,050 kilopascal.
Okay, 49,050. Actually, tidak payah kilo because kilo is kalau, okay, if you want to use kilo, then it will be 49.050 kilopascal. Baru kau bagi 1000. Okay, the unit for pressure is the same as all pressure lah, which is pascal. Okay, so 49050 pascal. Okay, so that's why I say don't look at this answer because this answer kan diorang pakai G sama dengan 10 bah. Okay, which was the old value. Tapi kamu punya batch kan, kamu orang sekarang semua pakai 9.81. Okay, that's why you won't be able to find the answer in here lah. Okay, alright, next question. The diagram shows a cylinder containing oil. Okay, so this is oil over here. Now the density of the oil is here. Okay, tell me what the pressure on this point is. Okay, we use the same formula, P equals to rho GH. Okay, 20 seconds. Saya membebel nonsense
Sorry,
kan?
sir. Tapi tidak sure kalau jawapan dia betul.
It's okay.
20.404.8
404.8. Unit
PA.
PA. Can you tell me how you got this? Macam mana kau dapat 20,404.8? Rho is obviously 800. Then gravity is 9.81. Kamu punya H?
Oh, kejap. Saya lupa tolak. Jadi, jadi 2.6 tolak 0.6 and then dapat 2 and then times 800 times 9.81.
Okay.
And then, kejap. And then akan dapat sepatutnya 15,696 Pascal.
Okay, very good. Okay, so the important thing, as I mentioned just now, is that the height must be from the surface to the this one. Okay, so mesti kamu pandai fikirlah kenapa ni dia bagi 2.6 lepas tu dia bagi 0.6 di sini. Apa dia punya trick di sini? Okay, alright, good job. Next question. I should have done a quiz on this kan instead of this one by one. Okay, so anyway, this answer is obviously wrong because dia pakai 10, kita pakai 9.81. Okay, the figure shows 3 containers with different shapes filled with water at the same level. Okay, the pressure caused by the water at point P, Q, and R are P1, P2, and P3 respectively. Comparison mana yang betul? Damir, ni terus ni, tak payah kira-kiraan ini.
A.
Sorry, did he say B?
A.
P1 lebih besar daripada P2 lebih besar daripada P3. So B. P1 lebih kecil daripada P2 lebih kecil daripada P3. So the pressure di sini yang paling kecil, pressure di sini paling besar. Itukah maksud kamu? Okay. So mari kita tengok jawapannya. Wah, seperti game show kan? Jawapannya adalah C. Ayah Damir. Okay, kenapa C? Can anybody tell me why C yang betul? Why is it that the pressure over here is the same?
Pressure not affected with any shape as long it is same height.
Very good. Okay, dia punya height saja yang penting itu. Dia punya bentuk itu tidak penting sebenarnya. Okay, so kalau macam saya dan Damir bahkan we are about the same height lah. Okay, ini contoh saja. Saya dan Damir kan kami punya ketinggian sama bah, tapi saya punya shape kan sangat besar and then Damir kan dia sangat kurus. Okay, tetapi our pressure, our liquid pressure lah, okay, is technically the same because we are the same height. Okay, so jangan terpengaruh oleh bentuk. Okay, bentuk tidak mempengaruhi tekanan dalam air. Okay, liquid pressure is not affected by the shape. You can be any shape, big shape, small shape, but the height of the water is the one that is very important. Okay, no worries Kalau salah tidak apa, kita belajar di sini. Okay, number 5. Equal masses of water are poured into 4 jars as shown. Which one has the biggest pressure? Let's see. Who should I call? Okay, Miss Tian.
A.
Why A? Not B meh? B is the bigger shape ma. Or D is the smallest area. Oh, the highest,
A is the highest.
Okay, let's check. Yay, A is correct. Let's all give Miss Tian a clap from wherever we are. Okay, so again, the same thing. Okay, but now this is a very important question because it says in which jar is the pressure by the water. Then you talk about the height. If we are talking about the pressure by the jar lah, okay, pressure yang dikenakan oleh jar itu dia bergantung kepada line factor. Remember that pressure is equals to force over area. So if the area where the surface is on is small, then the pressure is big. So if we are talking about the jar, kalau kita bercakap pasal tu bekas bahkan sebenarnya yang dia punya pressure paling besar. Because the surface that is touching the one kan ia yang paling kecil. But our topic today is only talking about pressure because of liquid. So we only look at height. We don't look at the shape at all. Okay, next question. Figure shows 3 wooden blocks J, K, and L are pressed into the water until the base reaches level P. So these 3 kena press level P. The pressure caused by the water at the base of the wooden blocks J, K, and L are X1, X2, and X3 respectively. Which comparison is correct? Okay, so you have these 3 blocks, and then pressure over here is X1, pressure over here is X2. Okay, kita kenakan lah, pressure caused by the water. Pressure over here is X3. So obviously you see X3 kan got more water yang touching it. No? Or X1 has more water, less water touching because it's so tiny, it's so kecil saja. Okay, what do you think? Daniel, which comparison is correct?
A.
A, you think that this pressure is bigger than this pressure and this has the smallest pressure because of the water.
Yes.
Okay, sorry, I'm so evil. I shouldn't be laughing. Sorry. Okay, so let's take a look at the answer. The answer is still C. Okay, because as I said before, pressure is not affected by the shape. Doesn't matter what shape you are. The only thing that affects the pressure on the object is how much height of the water there is. Okay, so we don't care about the shape. Okay, even though X1 is smaller, it doesn't mean that the pressure is bigger. Okay, because this is pressure caused by the water. Okay, pressure yang disebabkan oleh liquid. Okay, akan bertindak secara sama, regardless of the shape. Okay, so be careful with this, Daniel. Alright, number 7, siphon system. Okay, this is as I said yesterday, yang apa yang kalau kamu bela ikan ini kan, kamu mesti buat begini. Okay, read through the following 4 statements and tell me which is the one that is true. Rania, which of the following is true?
I think B. Water in beaker A flows into beaker B until the level of water in beaker A is the same as the level of water in beaker B.
Okay. Adakah jawapan anda muktamad? Do you want to use your 3 lifelines? Bodoh, macam who wants to be a millionaire. Okay, so Rana's answer is B, and yalah, the answer is correct. Okay, the answer is B. So water will flow from beaker A to beaker B, okay, because of the difference in the height. Okay, but the moment there is no difference in height, okay, when the water level is the same, regardless of the shape, guys, remember, regardless of the shape, okay, the moment the water level is the same, okay, there will be no water flow. Okay, the water will just stop flowing. That's why when you want to empty an aquarium, you always put one siphon above the other. Okay, especially kalau kamu betul-betul mau habiskan semua air lah. Okay, you want to make sure that all the water in the all the water in the aquarium keluar ke sini. Okay, so this is water lah. So you want to make sure that all the water goes in here. So that's why you create the difference in pressure. Because if you put it at the same level, once the water level here reaches the same water level here, doesn't matter, it won't flow anymore. Okay, so the difference in the height, okay, really makes a very big difference. And it also tells you how fast the water will flow up. The bigger the difference in height, the water will flow up faster. Okay, of course, if you have a bigger pipe also, it helps lah. Okay, all right, question 8. This is a calculation question. So diagram below, so obviously we have only one formula which is P equals to rho GH. Okay, water tank from this one, calculate the pressure at the water at X. X is over here, guys. So the problem is not the density or the gravity. The problem is what is the H that you're supposed to use. Okay, try to calculate this first. I'll give you this one. I will give you a little bit more time. Give 1 minute lah.
39240 Pascal.
Sorry, I heard
39240.
39240 Pascal. Okay. Tell me how you got the H. What is the H that you use?
Oh, I used the tank on the hill.
The tank on the hill, so your H is just 4.
Yeah.
If your H is 4, how do you get 39240 though? Tank on the hill is just, if your H is just 4 times
think
Okay, sorry.
I calculated wrong.
Yeah. Okay. It's okay. Anybody else got other answers? I'm just going to keep Louis' answer here first because I want to know how he got this H. Oh, interesting. Anybody else got different answer?
137340 Pascal.
137340 Pascal. Okay, so Louis's answer was H equals to 4 and you get this pressure. This is Melanie's answer. Okay, but what is your H yang kamu pakai di sini?
26 minus 16 plus 4.
26 minus 16 plus 4. Oh, so this whole thing minus this one. So you get this height lah. Okay, then you plus 4 because there's the water over here. Okay. So this is Melanie's answer. Anybody else? Anybody else got like different interesting answers besides this one? Same as Mel. Okay. All right. According to this answer over here, okay, the answer will actually be correct lah. Okay, you have to use the 14 meters because first of all, there is a difference in the you need to count from the tank all the way to the top of the water. Okay, so the H that we're using has to be 14. So 26 minus 16 plus 4 is 14. Then when you substitute the 14 into the H, you will get this answer. 137340 Pascal. Okay, so be very careful with the H lah. The H is always the tricky part, okay, of this particular subtopic. Okay, let's continue. Okay, sorry you know what, I'm going to skip this question because banyak kali kita kira sudah kan, so I'm like, no need lah. Okay, so this is pretty simple. Okay, let's talk about this, number 10. I discussed this yesterday briefly, but I just want to remind you again. The wall of the dam is much thicker at the bottom than it is at the top. So you remember the dam video we saw yesterday, dam, D-A-M, please, Wilson. Okay, so the wall of the dam is much thicker at the bottom, although this is the surface of the water. So why is this so? Okay, Elijah, why don't you answer this?
B.
Okay, B. Pressure at the water at the upper level is lower, okay, than pressure at the deeper level. Obviously lah. Okay, because the deeper you are, the pressure of water is bigger. Good. Okay. This is interesting. Let's do this. Okay, so diagram 7 shows two identical containers containing liquid P and liquid Q, two different types of liquid. Okay, when the height of liquid P is 15 cm and the height of liquid Q is 20 cm, the water spurt is the same. Okay, the density of P is 2. What is the density of Q? Okay. Try this first. We only use one formula. Okay, the formula is only one only. P equals to rho GH. Okay, give it a try. This is a very interesting question. Different height, but different containers, but the water spurt is the same. What does that mean? Okay, anybody?
The answer is C.
The answer is C. Was that Louis?
Yes.
Okay, Louis, can you tell us how you got C?
15 centimeter times 2 times 9.81 equals to, it should be 294.3. Then divide the answer by 20.
Okay, divide by 20.
And then it should get 14.715.
Okay.
And then
divide by 9.81.
Okay. And you get about 1.5 grams per centimeter padu. Okay. Yeah, I think Louis is on the right track. Okay. Cuma mungkin people are kind of wondering like, kenapa ini divide by 20 lepas tu divide by 9.81? Okay. So the important thing to know here is that since the water spurt is the same, okay, it means that the pressure is equal. That means the pressure over here, this rho GH over here is equals to this rho GH over here. So if I were to put it all in one line, okay, I will get this. Okay, sorry. You know what? I'm going to write it down now. So this rho GH is 2 times 9.81 times 15, as Louis said just now. Okay, very good. Then equals to this side punya pressure is sorry, the rho I don't know lah. The rho times 9.81 times 20. Okay, so even though there are different heights, but because the water spurt is the same. Okay, so this information over here is actually the thing that's very important for us to remember. If the spurt of the water is the same, means the pressure is equal. Okay, then lepas tu kau pindah, and you will get rho equals to 1.5 grams per centimeter padu. Okay, that's a very good attempt by Louis. Okay, good. Okay, let's talk about this. This one glance you should know already. So I'm going to ask Ava to answer this. What's the correct comparison between the pressures at P and Q?
Is it P?
B, Pressure at P is the same as pressure at Q.
No. C.
Oh, no. It's C. Why C?
Because the pressure di bawah lagi tinggi.
Okay, because the height is bigger lah. Okay, because the height is bigger in Q. All right. Okay, good. Let's talk about this. What is the water pressure in the tap? Okay, the water pressure in the tap. Okay, this one actually we haven't covered lah, but I just want to say that what you need to do is, after you get the pressure of the water, you add it together with the pressure of the atmosphere. Okay? You know what? I better do this for you. First of all, tell me what is the H. The water pressure is rho GH lah. But what is the H that I'm supposed to use? Can anybody tell me? Tap is here.
5.8.
Okay, I should use 5.8. So 1,000, okay, times 9.81, then times 5.8. Okay, what will my answer be?
56,898.
898 pascals. Okay, and this is because we haven't studied this lah. This is the next subtopic. So there is actually another pressure that is pushing the water down into the tap, which is the atmospheric pressure. Okay, so ini just introduction lah. We'll talk about this in the next class. Okay, there is actually atmospheric pressure on top of the water pressure that is pushing the water over here. Okay, so the total pressure, will be 56898 plus the atmospheric pressure, which is 10,000. Okay, 1.0 times 10 times 10 to the power of 5. I'm too lazy to think about how many zeros there are. Okay, so 1 power of 5 plus 56898, you should get 156,898 pascals. Okay, all together. So, but because we haven't learned atmospheric pressure, so don't worry about this now. We'll talk about this in the next subtopic. But all you need to know is that, okay, as long as you know how to count the liquid pressure, for today, that's good enough. Okay? All right, next question is, okay, let's talk about this. This will be very interesting. So the diagram shows two divers in a lake and a diver in a sea. Okay, so this is the lake and this is the C. The pressure of water at T, S, and U is PT, PS, and PU lah. So this is the diver T, diver S, diver U. Okay, take some time to think about this. Which of the following comparisons is correct about the pressure on the divers? This is interesting. This is a very good question. Okay, think about the factors that affect liquid pressure. The first thing I want you to tell me the first thing I want you to tell me is which answer is obviously salah. Okay, which answer is obviously wrong? Anybody? That you see one time, you already know, okay, this answer definitely wrong already.
B.
Okay, B will be out. Why?
The pressure S is the more slower.
Pressure S is supposed to be lower than pressure T. So bukan saja D yang out bukan saja B yang out, D pun tidak boleh sebab it's the same situation lah. Okay, so ini dua kita boleh potong. So now we have this conundrum. PU is more than PT is more than PS, or PU is equals to PT is equals to PS. So which of these answer is correct? A or C? Anybody lah? Saya malas sudah memanggil nama.
A.
Why A?
Sebab dekat laut dia punya air dia, density dia lagi tinggi.
Okay, very good. Okay, the density of seawater is higher than the density of lake water. Interestingly, okay, dia adalah air lah, okay, is actually water, but the sea is more dense sebab dia lebih banyak garam berbanding dengan di tasik. Saya bukan cakap okay, jadi harus kita minum air tasik lah. I'm not saying that lah. Okay, but if you give me a choice to drink between lake water and sea water, I will drink lake water lah. Okay, walaupun dia banyak lumut dan apa kan, tapi at least it's not salty lah. Okay, but sea water is very dense. Okay, compared to fresh water or lake water. Okay, so the answer would be A. Okay, because the density factor also memainkan peranan. Notice yang saya tidak cakap pasal bentuk. The bentuk doesn't matter. Okay, I hope that you understand by now the shape of the container, the shape of the lake, the shape of the body of water really doesn't matter. Okay, what matters is the three factors: gravitational acceleration, height, or the depth of water, and lastly the density. Okay, I don't talk about this. I don't talk about this. Okay, I want to talk about this. Okay, diagram 23 shows an empty bottle tied to a load in the water. Okay, so empty bottle over here, and then there's a string, and then there's a beban over here lah. So what changes will increase the pressure on the bottle? Okay, what do you think? Let's ask Iqbal lah. I always make the mistake of calling Iqbal as Elijah kan. So since I call Elijah, I must call Iqbal. What do you think the answer for this is, Iqbal? Shafiq, what do you think is the answer?
B.
Sorry, did you say D or B? Boy or
B.
Boy or
B.
Sorry?
B.
B. Okay, shorten the string. Yeah, the answer is definitely to shorten the string lah. Because when you shorten the string, the bottle will come down a lot further. Okay, but I want to talk about why is it now that okay, let's see, why can't we use C? Why can't we use a heavier load? Can anybody tell me why we can't use a heavier load? I wonder whether I'm asking a stupid question, but it sounds like a stupid question, right? No, but it's not stupid. I need the answer. Why can't we use a heavier load?
Because mass doesn't affect the pressure.
Because mass doesn't affect the pressure. Okay, so number one, your statement is correct lah, definitely correct. The mass doesn't affect the pressure. But I'm looking for a more logical answer. Somebody has typed
Because we want density of the bottle and not the load.
Because we want the density of the bottle and not the load. Okay, which is also true. Okay, but if you read the chat, Louis has the correct answer. Okay, we don't use a heavier load because the load sudah sampai di bottom bah. Kalau kau letak heavier pun it's not going to make any difference. Okay, so sometimes don't think so complicated bah. Like, oh, because mass doesn't affect the pressure. While it is true, it is true. Okay, but if you take a look at the situation, using a heavier load, okay, will not change anything. The load is already at the bottom. Dia sudah sampai di bawah bah. Kalau letak beban yang lebih berat, tiada juga bezanya. It's not going to sink into the ground. Okay, it's just going to stay there lah. Okay, thank you for trying.